Happy day, everybody. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Uh, we are going to present a topic in physics, and that topic consists of quantities, units, and dimensions. Before we go into this topic, please do not forget to subscribe, share, comment, and also make necessary sharing of my video on various social media. Thank you. Now, in physics, we have what is called quantity. Quantity. The word quantity simply means amount. Anytime you hear the word quantity, it's talking about amount of substance. Amount of substance. It's talking about how big or how small a substance we are referring to. Like for instance, let me give an example of length as a quantity. This length as a quantity, and if you have length P1, P2, if you compare it to length P3 and P4, we can see that this particular length P1, P2 is longer than length P3, P4. So we are talking about this quantity is more than this other quantity. So length is a quantity. And then we can also refer to height in the same way. Let me say we have height AB and we have height CD. You can see that this particular height is higher than this other height. So in a nutshell, length and height, they are example of a quantity. Now, we want to talk about units. What's the purpose of units in physics? Like for instance, I can give a scenario. Let me say we have two students in a particular class and they are bearing the same name. Let me call the first student Shegun and the second student Shegun. The first student Shegun, the second student is also Shegun. You see, if I, as a teacher, if I call Shegun, the two of them will answer me. In order to distinguish which of the Shegun I'm calling, I will have to put something like their surname. So their surname will distinguish which one Shegun from the other. In this case, that surname is standing in the place of what is called unit. So, in a nutshell, unit is describing the type of quantity we are referring to. Like for instance, let me say I have 5, 5, 5, 5. This particular 5 is a numerical value telling us the amount of quantity. Now, if I pick one 5, if I ask you which of the 5 have I picked, there is no way you will know which of the 5 I picked except I put what is called units. Like for instance, this first 5 here, I can take it as a 5 meter. The second 5 here, I can take it as a 5 Newton. This other 5 here, I can take it as a 5 Newton. 5 Newton. So this other 5 here, I can take it as a 5 kilogram, and this other 5 here, I can take it as 5 meter per second square. Now, in physics, we have quantity that is called length. So the length is this first 5. Why? Because length is measured in a unit called in a standard unit called meter. Then this other Newton is referring to force. The next kg, kilogram, is referring to mass. Then this 5 meter per second square is referring to acceleration in physics. Now, this length, force, mass, and acceleration that I've written here, they are known as quantity. They are known as quantity. Quantity. Now, each of the letter I put together with these numerical values, they are known as units. So this numerical value is talking about the amount of this particular quantity. So what am I trying to say is that a unit describes the type of quantity that we are dealing with. Describe the type of quantity that we are dealing with. Now, I want to also give us information on what a dimension is all about. In physics mechanics, we normally use two standard letters to represent dimension. I will tell you what dimension is. The first one is length L. The second one is length is M, letter M. Then the other one is letter capital T. This L stands for length. Then this M stands for mass. Then this T is referring to time. So we normally use this to represent what is called dimension. The question is, what is dimension? What is a dimension? What is dimension in physics? What is dimension in physics? Dimension is like a bridge that connects every quantity. It's like a bridge that connects every quantity with the fundamental letters. This particular letter L and T. So what am I trying to say is this: if you have a quantity, we can describe this quantity in terms of what is called dimension. So, like for instance, let me take force as a quantity. The formula for force is mass times acceleration. And then the mass, we can equally write it as mass. The acceleration is change in velocity. Change in velocity divided by change in time. That is what acceleration is all about. And then this velocity too is change in the displacement divided by change in time. The velocity delta v is change in displacement d divided by change in time. That's the v on top. Then divided by this other v below. So if I want to find, I can write this as letter F is equal to m times letter d for the change in d divided by letter t for the change in c, then times n divided by this other letter t. And then from the law of indices, this particular t here divided by this t actually means t raised to power 2. If you are so good in the indices in mathematics. Now, if I want to find the dimension of this quantity f, the force, I can put this bracket. This bracket is talking about dimension of f is equal to dimension of mass m times dimension of displacement d divided by dimension of time t squared. Now, like I said, in our dimension, I mentioned that anywhere you see length, we put L. Anywhere you see mass, we put capital letter M. Anywhere you see time, we put capital letter T. This particular displacement is more or less a distance in a given direction. And distance is a form of length. So if I put this one out, therefore dimension of F means the dimension of n is capital letter M times dimension of the velocity is letter L, then divided by dimension of t squared is letter T, capital T squared. From law of indices, if you carry this positive power up, it will become negative. So the dimension of force is equal to M L T raised to power minus 2. So in a nutshell, dimension actually show how derived quantity is related to fundamental quantity, because mass is a fundamental quantity, length is a fundamental quantity, and time is a fundamental quantity. So this dimension I have here is like a bridge that connects derived quantity with a fundamental quantity. Now, this one now brings us to another aspect of our topic, and then this topic is this particular unit type of units. Let me go to type of units. Now, you see, like I said, units, give an idea of the quantity we are talking about. At times, when we have a very large quantity, that means we need to associate that large quantity with a multiple of its respective units. If you have a very small quantity, that small quantity we have to associate it with the respective small units. So, like for instance, when I talk about large quantity, like the mass of the planet Earth, you know that planet Earth is very huge. So the units will be in a multiple, a very large unit. And then concerning small quantity like atom is very tiny. So the quantity will be expressed in subunits. So two types of units that we have. The first one is called super units. It's called super units. And the second type of unit is known as the subunit. Now, in order for us to remember these super units and subunits in physics, I've put up what is called a mnemonic. Like for instance, these super units, I put these mnemonics. King Michael gives them power. King Michael gives them power. So because we call it super units, we are going to use capital letter for super units. I will tell you what I mean by that. Then for the subunits, smaller units, we are going to use small case letters. So for the super units, I use this mnemonics. The first letter of king. Okay, the mnemonics is I made the statement. King Michael gives them power. The first letter of king is capital letter K. Then this letter for Michael, the first letter is capital letter M. And then the first letter of gives is capital letter G. And then the first letter of then is capital letter T. And the first letter of power is capital letter P. Now, this K is called kilo in physics. This M is called mega in physics. This G is called giga in physics. Then this T is called tera in physics, and this P is called it's called King Michael gave them power. Stop. Better. Now, this particular super unit for kilo, we start with a base of 10 and power of 3. So for the kilo, we start with a base of 10 and power of 3. To generate others like this mega now, let me write K for kilo, M for mega, then G for giga, T for tera, P for peta. Now, I will put base of 10. All of them will have a base of 10. I'm starting with power of 3. To generate the power of these other superscripts, you add 3 subsequently to this first power. So 3 plus 3 will give us 6. So this one will give us a raised to power 6. When you add 3 again to 6, we have raised to power 9. When you have 3 to 9, we have 10 raised to power 12. Then when you have 3 to 12, we have 10 raised to power 15. Now, for the so that's what we have here. Like for instance, let me give an example under super units. Like if I write a 5 kilometer, the meaning of this K is 10 raised to power 3. So we can write it as 5 times 10 raised to power 3 meter. We have converted this expression from kilometer to meter. So this one can also be written as 5,000 meter. You can see. If I want to have peta, let me see 5 peta, let's say meter. It actually means peta is 10 raised to power 15. Channel means 5 times 10 raised to power 15 meter, and so on and so forth. Now, we are going to the subunits which we use in dealing with measurement of small quantities. In this subunits, we use small case letter. Now, I use these mnemonics to remember the arrangement of the subunits. I start with mom may not pick Femi. Mom may not pick Femi. The first letter of mom is M. But this other, because I'm having first letter M here, I'm having first letter N here, I cannot write N here. So what I will do is to write this M with a longer leg. So this one is called micro. This first one is known as milli. This one is called micro. Then this letter here, that is letter N, the first letter in not is letter N, is called nano. And then the first letter of pic is P, is called pico. And the first letter of Femi is small letter F, and is called femto. Now, how do we generate the milli of milli? Each of them also start with 10 raised the base of 10. So we are start milli simplified from the word millennium. Millennium means 1,000. But when we talk about milli, it's a fraction, a 1,000 expressed as a fraction. So this milli is actually means 1,000, but we write it as a fraction, 1 over 1,000. And for your law of indices, we can write it as 10 raised per minus 3, because this 1,000 can be written as 10 raised per 3. And when we carry positive power up, it will become negative. So milli actually means 10 raised per minus 3. So we start with letter M for milli, 10 raised per minus 3. So to make it faster, what I will just do is to put the power of the superscripts, that is 3, 6, 9, 12, 15. I just put negative sign on this power. So let me list this standard out. I write 10 raised per 3, 10 raised per 6, 10 raised per 9, 10 raised per 12, 10 raised per 15. Just put minus with each of the power. So that is negative. So the next sub unit that I'm making reference to is micro. So this 10 raised per minus 6 is that micro. So the next one is nano. So 10 raised per minus 9 is nano. That's small letter N. Then the next one is pico, small letter P. That is what 10 raised per minus 12 stands for. Then small letter F for femto. That one is 10 raised per minus 15. Like for instance, if the question says change 2.4 micrometer to meter in physics, like I have said, this micro in my listing is actually means 10 raised per minus 6. So I can write this expression as 2.4 times 10 raised per minus 6. Then I write this meter with 6. You can see the conversion. Let me give another one. Let me say the question say change 2 piconewton to Newton. Pico means 10 raised per minus 12. So this P is actually 10 raised per minus 12. So you write it as 2 times 10 raised per minus 12 Newton. You have done the conversion. Thank you so much for listening to my video. Once more, please do not forget to subscribe, to like, to share my video across other social platforms for more engaging class. Thank you so much. Orekoya Olusegun Physics Mathematics Fundamental. Happy day.